So we're going to start looking at building a prop controller. So this is one of my PCBs that I make the design available. Very, very cheap to make. This cost me $2, and you can see it's nicely made, just the right size to go in the boxes I make, and very easy to mount up. So all these props you can build up yourself. Just hand wire this to this, to hand wire this to this. It can start to look like a total mess very quickly. You can also use Veriboard, strip board, but using a real PCB is much easier to do. So today we're going to mount up the basics of controlling the rack. So we need an Arduino, which is a microcontroller board. We need an audio player. This is called a DF Player Mini. You need a micro SD card to go into the player. That stores your audio. You need a small power supply so that we can power the Arduino and some of the other pieces from a 12-volt input. You need a power input. I'm using a straight 2.1 barrel lead. This will come in at 12 volts. You need a PCB. You need a loudspeaker. It's just one random one I grabbed. And then you need some of these. These are called header strips, and these are called socket strips. Now the socket strips you can buy in these long lengths. They're pretty cheap, and then you can actually just pull out connections you don't want, snip them to length, and you can make them adjust. So when I put in my Arduino, I don't want to solder it directly in because I might change it, might not use it. So I'll just count off a piece of socket strip this long, pull out a pin, solder two of those, and then I can pull the Arduino in and out as required. The other connections we're going to need on here, we're going to need a connection for a PIR, we're going to need the speaker connection, we're going to need a couple of motor drive connections, and that's actually about it on this one. Some of the others you can drive up to 3 servos, or you can have direct link to audio LEDs, relay controls. It's super flexible, you know, what you can do with the thing. And it supports both the Octobanger firmware, but also basically just homemade code, which is a lot easier to write for some props. So what I'm going to do now, I'm going to start soldering the headers onto here. I'm not going to give a tutorial on how to solder. There's plenty of those on the internet already. But basically we're going to put the headers on here. We're going to put some sockets in here. We're going to put some pin strips in here as well. Once I've got them ready to go, then I will then get around soldering them and show you what it looks like before and after. Worth looking at a quick look at soldering equipment to do this sort of thing. You don't really need anything fancy. You can use one of these really basic irons. I mean, the tip's kind of big and chunky, but you know, they're cheap, they get the job done. All you really need then, you know, you need some solder. This is you know, lead silver solder. You're going to need probably a pair of tweezers, maybe some pliers, and some sharp side cutters. These are dirt cheap, all of these bits of tools. Once you get a bit more interested, you could get something like this soldering station. It's got a soldering iron this side. You can change the tip sizes on them. This is a sort of fairly chunky one. I can go smaller. And also it has hot air, so you can use this for heat shrinking or getting stuff off of circuit boards. They're pretty versatile. Also, this one also has a power supply, so you can power some of your mini projects as well as a USB. It's a pretty good piece of kit, and they're about $100, somewhere around that region. The other thing that's probably useful if you're a little bit older is some sort of magnifier. Now I have a full-on microscope borrowed from work, which I don't need. This thing would set you back probably $500. You don't need the thing for this type of hobby electronics. One of these is absolutely perfect. It's got a 5 times magnifying lens. It's got a really nice light in there, and I don't know if I can show you it when the thing's in there compared to when it's out. It's difficult to tell with the thing, but it's it gives a lot of magnification, and it's just right. It's also great for painting and stuff like that. Okay, so here's me building the prop controller. I've sped it up by
2 times. You can slow it down in YouTube if you want. First thing I'm doing, putting some headers onto the Arduino. What I typically do is just tack them down, literally one random pin each. Then I check the alignment, see that they're all square. They're going to stick down nicely. That's what I'm doing there. If so, then I'll tack down another couple of pins and then start to then finally do all of the pins together. To make sure my joints are nice, I'm looking under the microscope. I haven't got quite the right angle there. Apologies for the head and the ear in the way. But effectively, you're heating up the pin and the pad at the same time. You're flowing solder in, and you're looking for a sort of mountain style shape ideally. Okay, Arduino's done. So now we're going to make some socket strips that go in there. So what I typically do is I look at how many I need. I pull out the pin I don't need, snip them to length, and then basically double check that they fit. Make 2 the same. The long socket strips like this are way cheaper to buy and chop up than buying the ready-made short ones. So if you're a pikey like me, it's a good way of doing it. And again, for fitting these, I tack down a couple of random pins, then I look and get them straight. You can see one is about straight, one is horribly off. So I remelt the joint, just get them square all the way through, and then I'm going to go around basically and solder up all the rest of them. Again, should probably do this under the microscope. In actual fact, look what I did there. I used one of the mounting holes instead, so the things were offset. I'm trying to do it in a hurry, so now I've had to pull the thing out again. And now I've got pins with solder in them, which I've now got to get out. So to do this, I'm putting a little bit of flux on those 2 pins. Then I'm using something called a solder sucker. It's a little vacuum operated thing. Basically pulls the solder out of the hole just enough so that you can get the thing back in again. So now I've got it in the right place. I'm going to carry on and solder the thing up. Checking my work under the microscope, both sides, and you see that when they're plugged in, all matches up. And then, because we don't want to risk damaging it, we're going to take it back out again. Next thing to add is the audio module. That already comes with pins on. Just to get a little bit of height, because it's easy to plug the card in and out, I've just lifted it up just to give us some short solder tails on the bottom. And here, just going to solder up the pins. Again, start in the corners and then just work yourself all the way around. Note on these things, you don't actually need to solder all the pins on the audio module. Most of the signals are on the one side. I think there's only a ground pin that you're interested in on the other side. So if you don't have to solder it, don't bother. Next thing to fit's the little power supply. So I'm going to break up a socket strip into little 2-pin ones. Again, it's cheaper to buy the whole long lengths than it is to buy shorter ones. And then what I'm going to do is just tack down a pair of them at a time. See if they're square. One of them was, one of them wasn't. Apologies for the hair again. And then I'm going to do the other pair as well. So on these little power modules, some of them that they have power in coming in one side and power out going out the other side, and then you've got basically a double pair of ground pins for the return currents. Okay, just double check my soldering under the microscope. Plug in the power, and you see there's a little arrow telling you which way to go. The silk screen on the board kind of shows it too. So it sits on top, and then I'm just going to solder those down as well. And again, I'm sorry, my head's in the way again there. I need to improve my positioning for this sort of thing on the top of a bench. Once again, just check your work as you go. Make sure you don't get any solder splashes on things. The next thing I'm going to do is break out some strips into the 3-way ones or the 1-way ones. And these are going to go into the various different sort of locations I need. So these are for the PIR mode and for the PIR sensor. And then the ones down here, the 2-way ones, these are for the MOSFETs. So on the unit I was building here, I think it was for my medieval rack. So there was one was for lighting. I can't remember what the other one was for.
So a couple of things I forgot to mention. You need another few bits. If we're going to switch lights or anything from 12 volts, like a motor, you're going to need some of these. These are MOSFET transistors. They're going to fit inside these little holes, and they're going to solder underneath here. They're very cheap, especially when you buy them in bulk. We're also going to need a connection for the speakers. I forgot to solder that one in, so we'll solder that one in there. Then we need some capacitors. Well, this already has capacitors on. The little Arduino has some capacitors on, but they're not very big. So what can happen is, as soon as you start to run things, you start pulling current, you start to get random weird behavior. So we're going to put some of these capacitors in. These are called electrolytic capacitors, and again, very cheap. We're going to put this little boy in here, and there is a little marking that says minus on it. Make sure you get the minus and the plus the right way round. If you don't, you might get the odd pop and bang. That's the capacitor for this little guy. We're also going to put one on our main 5-volt rail that comes out of this thing. But before we do so, we're actually going to power this up and adjust it. It's a tiny little adjustment screw with a meter to make sure we get 5 volts on here, because we don't want to be passing too much through. It can potentially damage things. This 5-volt supply could power the relays, it could power the servos directly, the PIR sensor, and if you get this wrong, you could blow all of those things up, which we clearly don't want to do. So I'm just going to put a meter on here, and then I'll show you how we basically just adjust it. Okay, so this is another useful thing for one of these power supplies. I've got 12 volts coming out, going into the input of this voltage regulator. I've got a digital multimeter. It's set to DC volts up to 20 volts. And I'm just going to put the connections on this output. And you can see it's actually giving me 11 volts out. So if I'd put that on something that only expected 5, we could see some blue smoke. So what we've got to do, and this is awkward for me to show you, is I'm going to adjust with this tiny screwdriver the little tiny resistor. You can see there the voltage dropped quite dramatically with a little turn, and it's going to come down again, and you know, I want it somewhere around 5.1. That's perfect. So that's all I need now. Don't need to set it again. If you're really worried about knocking it, which is very difficult, you could put some glue on it or a little bit of electrical tape. Now we've got 5 volts set up, we can go out, carry on. I'll build the rest of the board.
Okay, so I've double speeded this job as well. Now, but it's basically soldering all the last bits of those. So there's the speaker headers going in. Just checking them again. And once again, apologies for the abysmal angle. This time you have my arm in the way rather than actually seeing what you're supposed to be seeing. Now I'm fitting the MOSFETs in there. Oh no, not quite into the MOSFETs yet. Oh, those are the capacitors. So the capacitor leads are always really, really long. So you poke them through, fan them out a little bit, solder them both, and then with some side cutters, you trim them off. So once I've got all my capacitors in place, then I think probably the next thing will be the MOSFETs. In case you're wondering what the 423 is in the background, that's the temperature of the soldering iron. So that's in centigrade. That's pretty hot. But what I've found with these irons, really, you don't really get the proper temperature out of them. So you generally have to crank them up a little bit more to get some heat out of them. It's not like you're using a really nice iron. But they do work, and you can change the tips, and they're pretty cheap. So now I've fitted the 2 MOSFETs. Again, using the side cutters just to trim the leads off on the back of there so they don't stick out.
Now you may have noticed on the board you've also got some what we call surface mount parts which go underneath the board. So these are little resistors, often used just for things you may or may not want to do to the circuit. You know, I may need a pull down on that one, I may need something in that, I may need something in that. So it's basically done such that you can change stuff around in this board anyway. And the only things that I really need is I do need to solder a 1 kilo ohm resistor to one of these sites over here, and that's required basically to just cut down noise between this little mini player and the main Arduino. What happens is you get weird clicking and stuff like that, like a sound like that in your speaker. So with a 1K in there, it limits that digital noise and stops that happening. So I'm going to fit one of these, and then I'm just going to look at the circuit to check I don't need any of the others fitting, which I don't think I do. And then the last thing to do is basically connect up a power cable, and the basic board is complete. So this is where our magnifier is really useful. I mean, these are not small by any means compared to modern electronics, but they're still a bit of a pain unless you've got really, really good young eyesight. So all I'm going to do is peel back the package here and get one of these resistors out. As I say, that's compared to modern ones, that's actually quite a large part. What we're going to do, I'm going to put it down on the site called R1, and then I'm just going to put solder each side of the thing. My favorite way of doing this actually is to put just a little bit of solder on one pad, doesn't matter which one, and then with your tweezers slide the resistor into that pad while heating it up. Okay, it will solder in, take your heat off, then you can go around to the other pad. You know, the parts are already in position, and then you can just complete the joint. Very easy, quick to do. Yeah, you could use through hole ones, but in the interest of keeping it clean, I went for the surface mount one here. And then, as I said, we've now got to put the power cable on. So this sort of power cable here is just something bought off Amazon. It's already got some pre-tinned connections. What I'm going to do here is basically fill these holes on this board with some solder and then melt this into there. When you actually get it in the final unit, you may need to strain relief it, put some Hot glue on there is great just to hold the things in position so they're not going to accidentally get tugged out by. So a very basic quick test to see whether the thing is been soldered up now. I'm actually using my bench supply again to supply 12 volts in here. You'll see a very quick surge of current there. That's basically the capacitors filling up with charge. And then you'll see nothing because they're not being used for anything. If you actually want to quickly check some voltages, just to check that you've not got anything wrong, now's a good time to do it before we plug anything else in. If I put them across here, for example, I've got my 5.1 volts I adjusted. This guy over here, if we turn it over, should be nothing on it at the moment because that's powered by the actual Arduino itself. So now we're safe to turn off the supply, plug in the Arduino, and back on. You'll see that the lights automatically come on. The Arduino ships with a basic sort of blink program, I think it is. And it's worth checking nothing's going silly. You know, put my probes on, I'm getting the same voltage there. And if I now probe across the back of this one, you'll see that I get 3.3 volts. It says minus because I've got my probes the wrong way around, but it's 3.3 volts. So that shows the regulator is working on this board to power itself, and also the regulator to power this guy as well. So there you go. We've basically completed the basics of any of these prop controller builds. I mean, if you were doing one with relays, you'd solder them in here. If you were doing things with servos, you'd connect them here. But for a basic build where you're turning lights on and off, you're using a PIR, which is going to be wired into here. One of these standard PIRs, again, very cheap to buy, turn the thing on and off. And then we're going to wire our speakers into these pins over here so the thing can drive the speakers directly. So this has a little mini amplifier which allows us to do that. Very quick to do and cheap as well.